7-4 two-way tables. We're going to be constructing two-way tables and interpreting what's called two-way frequency tables. This is when you have two different categories that are being associated with each object, and those are going to be classified a little bit differently. So a two-way table is just a way to organize data that has two variables. So a way to organize data that has two variables. You can look at this very controversial question in the corner. Do you like broccoli? So do you guys like broccoli?
I mean, like,
Ranch.
I mean, like, I'll eat it.
Broccoli's probably one of my favorite vegetables.
Over carrots?
Actually, I've been having broccoli and carrots with my lunch. I like the
Carrots and corn.
Yeah. They got that crunch.
Oh.
All right, so they asked children and adults, do you like broccoli? And there are two columns. And then what you want to do is find the total number of people. The way to find the total number of people, there's two ways. You can total up the yeses, total up the no's, add them together. Okay, so the yeses, 10 people said yes, 10 people said no. So the total number of people is 20. You could also go by the rows. Okay, so there were 11 children that were asked, and there were 9 adults that were asked. Okay, so again, when you add them together, you get 20. So we are going to be using those totals. Okay, so that's your two-way table. The two variables are yes and no to the broccoli, and are you a child or are you an adult? Okay, and then the joint relative frequency. So like I said, these are some heavier vocab words, bless you, but they are going to come naturally as we go through these. So this is the joint relative frequencies are the values in each category divided by the total number of values. Okay, and these are going to be the shaded values in the table. So we're going to shade these in. So these values were formed by dividing the number by the total. And we're going to write those out. So the joint relative frequencies, we're going to use this table here. So again, remember we said that the total was 20. You have the 10 and 10, so the total was 20. Okay, so for this one, this is the yes of children. How many children said yes? 3 out of 20. So how do I turn this into a decimal? Just divide it. So 3 divided by 20, that's how you get the 0.15. Okay, that's where this came from. So you're going to be making your own. We just want to know that, I just want to know that you understand that. So for this particular yes, for adults, that would be 7 over 20. So when you divide, you get the 0.35. That's where it comes from. For the no, the children, is 8. So 8 out of 20 as a decimal is going to be 0.4. And then there were 2 out of 20, which is going to be 0.1. Okay, those are called the joint relative frequencies. Okay, so you just divide to find them. The marginal relative frequencies is the sum of the joint relative frequencies. Okay, so this is the sum of the joint relative frequencies in each row and column. So it's very similar to what I showed you up here, right? Remember how I added straight down, I added straight down? That's how you get 0.5. 0.15 plus 0.35 is 0.5. That's a marginal relative frequency. Add the nose together, 0.4 plus 0.1 is 0.5. And then you do the same thing but with the rows. So 0.15 times 0.4, 0.35 plus 0.1, there you go. Now, the only other number that we have is this number 1. This number 1 here is the total, and in probability, 1 is the highest because it represents 100%. So this represents the whole. So that should always be 1. If you round and you get like 0.999, it's just because it rounds to 1. Okay? And then the conditional relative frequency is the quotient Okay, the quotient, when you divide the joint relative frequency by the marginal relative frequency. Okay, and we don't have that in the table. That's going to be situational. Okay, so they'll give you a condition for that. All right, so we are going to do example 1. The table shows the results of randomly selected car insurance quotes for 125 cars made by an insurance company in 1 week. We're going to make a table of the joint and marginal relative frequencies. Okay, so that's what we shaded above. The joint and the marginal is just this, and then the blue. Okay, the green and the blue. All right, so the first thing it says is find the total number of people represented in the table. Now they told you in the directions that it was 125, but you could do this yourself by just adding the rows. 15 plus 53 is 68. 4 plus 32 is 36. 9 plus 12 is 21. And then just add all of these together. 68 plus 36 plus 21 is going to be 125. Okay, so to make the new table, all we have to do is take our numbers here and divide them by what? 125. Okay, so for the teens, 0 accidents, there's 15 out of 125. Man. That's kind of scary. Okay, and then when you divide, you should get 0.12. Okay, and then for the next one, you would do 4 divided by 125. You do not have to put this fraction. I'm just going to put it for the first column as a reminder for how you're getting these numbers. And then I'm going to have you do the second column. Okay, so then you do 9 divided by 125 to get 0.072. And then this one is the total. Okay, so for the total, you are going to add these decimals together. Okay, and then you are going to do the adults. Okay, so do the adults here. Okay, so 300, wait, tell me what you got for this one, the first one.
I got like 4, 3, 4.
Yeah. Good. Aiden, L, tell me what you got for the next one.
.256.
I was going to call on you for the next one. Other Aiden?
Oh.
I was actually going to call on you for the next one. And then Aiden 2.
.096.
Good. All right. And then when you added them up, what did you guys get for your total? Great. Good. Now when you add these two together, what should that be? Yes. All right. And then we're going to do this total. So when you add these two together, you should have got .544. Okay. And then you get .288, .168. Okay. And then again, when you add these three together, it should make 1. Okay. And you can, these were exact here, but if you have to round, round to the nearest thousandth. Okay? All right, so we're going to finish